JEE Advanced 2025, Paper 2, Physics, Question 13. Let us visualize the setup. We have a thermally isolated container of length L. A thermally conducting, movable piston of area A divides it into two compartments. The left compartment has 3/2 moles of ideal gas, and the right compartment has 1 mole. A spring with spring constant K and natural length 2L/5 connects the left wall to the piston. In equilibrium, the piston sits at the midpoint, L/2 from each side. Let me keep this diagram as reference while we work through the problem. Here is the question. A thermally isolated container of length L has a thermally conducting movable piston of area A. The left compartment has 3/2 moles, and the right has 1 mole of ideal gas. A spring with constant K and natural length 2L/5 connects the left wall to the piston. In equilibrium, the piston is at L/2 from each side. If pressure in the right compartment is P equals KL alpha divided by A, find alpha. The key concepts for this problem are, first, Hooke's law for the spring force. The spring is stretched, so it pulls the piston back toward the left wall. Second, piston force balance at equilibrium. The net force on the piston must be 0. Third, the ideal gas law PV equals nRT applied to each compartment. And since the piston is thermally conducting and the system is in thermal equilibrium, both compartments are at the same temperature T. Let us solve this step by step. First, finding the spring extension. The spring's natural length is 2L/5, and the piston is at L/2 from the left wall. So the extension delta x equals L/2 minus 2L/5, which is 5L/10 minus 4L/10, giving us L/10. Next, the force balance on the piston. The spring is stretched beyond its natural length, so it pulls the piston to the left. Taking rightward as positive, the left gas pushes right with force P left times A, the right gas pushes left with force P right times A, and the spring pulls left with force K times L/10. For equilibrium, P left times A minus P right times A minus K L/10 equals 0. So P left minus P right equals KL over 10A. Now applying the ideal gas law. Both sides are at the same temperature T because the piston is thermally conducting. For the left compartment, P left equals N1 RT over V1, which is 3/2 RT over AL/2. Simplifying, P left equals 3 RT over AL. For the right compartment, P right equals N2 RT over V2, which is 1 times RT over AL/2, giving P right equals 2 RT over AL. Substituting into the force balance equation. P left minus P right equals KL over 10A. So 3 RT over AL minus 2 RT over AL equals KL over 10A. This gives RT over AL equals KL over 10A. Solving, RT equals KL squared over 10. Finally, computing P right. P right equals 2 RT over AL. Substituting RT equals KL squared over 10, we get P right equals 2 times KL squared over 10, all divided by AL. Simplifying, P right equals to KL over 10A, which equals KL over 5A. Comparing with the given form P equals KL alpha over A, we see alpha equals 1/5, which is 0.2. The correct answer is alpha equals 0.2. The spring stretches by L/10, creating a force imbalance that allows the left gas with more moles to have higher pressure. Through the ideal gas law and force balance, we arrive at P right equals KL over 5A, giving us alpha equals 1/5, or 0.2. Here are some important tips for thermodynamics and mechanics problems in JEE Advanced. First, always check whether a spring is stretched or compressed by comparing current length with natural length. This determines the direction of the spring force. Second, for thermally conducting walls or pistons, remember that both sides reach the same temperature at equilibrium. Third, in piston equilibrium problems, carefully account for all forces including gas pressure and spring force, with correct signs. Fourth, when the question gives the answer format like P equals KL alpha over A, compare your result directly to extract the numerical value. If you found this solution helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next one.